Well, hey everybody, welcome back to Master the NEC, where we're talking about grounding electrode systems. And we've worked our way all the way up to part 4. So if you're just getting into this program, we started out with 250.50. That was back in part 1. And we talked about the metal underground water pipe. Hopefully you've watched part 1. In part 2, we focused on in-ground steel. That's like I-beams down in the earth or encased in concrete at least 10 feet in the earth or driven 10 feet in the earth. We talked about those and we went over the details of those types of electrodes. And then we moved on to a concrete encased electrode and talked about what constitutes that. And then we moved on into ground rings in the last episode. That was part 3. And we even talked about probably the most common electrode, which is ground rods and pipes. Pipes not as popular, obviously, as the rod. But we talked about the nuances. And so far in this series, what we're talking about is the electrodes. We really haven't talked about the installation practices, the sizing of the grounding electrode conductors, and they go down to the electrode. We haven't talked about all those little nuances, but we will. But before I get into that, I want to remind you that if you want to get more than just the kind of things that we're talking about, you really want to increase your knowledge of grounding and bonding. This whole program is part of what comes out of our Fast Tracks Purple program. Now, it's a program that we have that teaches you grounding and bonding. And so these lessons that I'm doing in this video series are basically from that course. And so the illustrations are there, the discussions, the details, systematically moves you through it. So there is so much more other than just the grounding electrode system. And obviously in this series, we're going to get a little deeper because we're going to talk about installation practices as well moving forward. So make sure that you subscribe to the channel and that you click the notification bell if you're over on our YouTube channel, because that's where you can get notifications when our videos come. And as I promised, 2022, we had a lot of videos scheduled and we're just cranking them out. And we're going to be educating you on residential, commercial, exam prep, grounding and bonding, because we have courses on all that. So visit our website. Do me a favor. Go to electricalcodeacademy.net and look at our green, our red, our blue, our yellow program, this program, the purple, as well as our black program, which is for exam preparation or general knowledge of the NEC. I appreciate you taking the time to watch this video, and hopefully you'll share it with somebody who wants to learn about electrical codes, because that's what I'm here for. I'm not here to teach you how to install conduit. Anybody will learn to do that with time. And I don't like watching videos that have other people doing it because it's not relevant. That's their install. But code, you all need to understand how to do. And I'm keeping these short and brief so that they teach you something and you can actually make it through the entire video rather than my normal 2 hours or 1.5 hour type videos. Okay? All right. So we're going to pick up where we left off. So hopefully you go back and you've seen part 1, part 2, part 3, and we're getting into this series. So let's go on and get to the lesson and pick up today's topic. All right. So we've talked about A1, A2, A3, A4, and A5. We're now up to A6. Now, A6 is the one that says other listed electrodes. So manufacturers could make an electrode, and you're going to see an image of one here. It's listed, and it is designed in a certain way. And of course, it's got its own instructions on how you install it. You put it in the ground. In other manufacturers, so the reason this says other listed electrodes, because this opens the door for the manufacturers to make other types of electrodes and get them under this. But the one that's probably the most common under the other listed electrode is the one that utilizes a chemical process. And so we're going to kind of look at that, but I'm going to read the code first. And again, as you see in the other ones, we're going to go look at the code and then we'll come back and we'll read the commentary. So here we are in the code. And as you can see, 250.52A6 is short and sweet. It says other listed grounding electrodes shall be permitted. So it's got to be listed. So a manufacturer has to provide it, and it's got to be listed for use as an electrode. And it'll give instructions on how you make connections to it, whether you exothermic weld to it or whatnot. Follow the instructions, okay? So just wanted to touch that. So now let's go on and get back. And we're going to go on and look and see what this might look like. We've never seen one. Also, let's go on and look at the discussion real quick. It says this section intends to recognize grounding electrodes other than those mentioned in other subsections of 250.52a. That was the pipes, the rods, the in-ground steel, the water pipe, underground water pipe electrode, and the concrete encased electrode. So this is an other type. It included are copper tubing grounding electrodes that are listed and have been available for several years. These are known as chemical rods because they typically have chemicals inside and approximately 2 inches of copper tubing and weep or drain holes to permit the chemicals to leach out into the soil to enhance that connection to the earth, okay? That chemical bond between the actual chemical rod, which is the outer 2-inch tubing, and all the chemicals that are inside of it. Now, typically there's an access port to get there because you'll need to add more chemicals over time. So there is maintenance involved in these, okay? These rods cannot be driven. You actually have to dig them and put them in the ground. So you got to excavate to put them in, okay? And it says an access cover is usually provided to permit, again, chemicals to be added as necessary. A typical installation to the vertical or horizontal type chemical rod is shown here. So let's an illustration. So here it's got a UL plate on it, okay? So it's listed, and it might be it might be UL, might be CSA, it might be another type of nationally recognized testing laboratory that produces it or that lists it. Manufacturer's choice, who they want to go to. And here you go. So there it is, and you see there's holes on it, leaches out. And here's one that goes down that turns horizontal, and you see you get with these electrolytic roots that come out through the holes with the chemicals, and it leaches this out. But there's instructions for how these are made, okay? They're usually like a bentonite clay, and then you've got a certain type of stone around them, and you're going to have a CAD weld connection, and it usually comes with a little pigtail on it, and you have to make those connections, okay? And you're going to have an access well because you're going to have to get there to refill it with chemicals over time, right? So that's something that you're going to run into, okay? It's important to carefully follow the manufacturer's instructions here, and critically important, because if you don't, then it might not be installed properly. And you can't rely on it to be there when necessary for lightning or transients, whatever's trying to get to the earth. You can't rely on the electrode if it's not installed properly, especially with these because they're listed. So the instructions that come with it are part of the listing, okay? So you definitely want to make sure that you follow these. Google it. Look and see if you can find them out there. I have never in my 30 years, I've seen them, but I've never installed one, never had a need to install one. But if you're in a part of the country that you just can't get very good ground resistance in it, now remember the 25 ohms thing, that only applies to rod, pipes, and plates, not to these. But if you were in an installation where they really need low ground resistance, then this might be the answer. I don't know. Your engineer might specify it. All right, the next one we're going to look at today is probably not as popular as some of the others, but it is called a plate electrode. Now remember, I said earlier, rod, pipes, and plates, those are required to be 6 feet apart, each one of those. So rod to rod, rod to pipe, rod to plate, pipe to plate. Those are required to maintain 6 feet separation between those. It doesn't apply to the other types of electrodes, just rod, pipes, and plates, okay? They have to have that 6 foot separation. But that's for a different time, and we'll cover that in more detail, and I'll even point out why. Now, let's look at what the code says, 250.52a7 for these plate electrodes. Because remember, in this series, starting out, we're just kind of dipping our toe in it, right? We're looking at the electrodes. So the plate, it says, each plate electrode is required to expose not less than 2 square feet of surface to exterior soil. Electrodes of bare or electrically conductive coated iron or steel plates must be at least 1/4 inch thick. Solid uncoated electrodes of non-ferrous metal, like a copper, are to be at least 0.06 inches in thickness. Okay, so if you look at the illustration, if it's an iron or steel plate with a coating on it, that has got to be at least 1/4 of an inch thick. But if it's a non-ferrous metal like the copper, then it only has to be 0.06 inches thick. Okay, but it has to expose not less than 2 square feet. Now, it's not 2 square feet just on one side. Remember, there's 2 sides to these things. Okay, so collectively you can get the 2 square feet from that. Okay, and we're not really getting into how deep they have to be yet. Well, that's for a different episode. We're just talking about the electrodes again. So for those that are impatient, we'll get there. But right now, we need to better understand the electrodes. So these literally are plates, and they are manufactured, and usually you'll CAD weld to these. Okay. Now here's a discussion. The code interpretation of the requirement to expose at least 2 square feet to the surface of the soil is that of plate electrode is measured 1 foot by 1 foot, meeting this rule because both sides of the plate are in contact with the soil. Now, I've heard people say, no, I want it to be at least one side to be 2 square feet, right? But you have 2 sides to this thing, okay? All right, so anyway, installation requirements are at 250.53 A and B. That tells us the depth it needs to be, and we're going to cover that in upcoming episodes. We're kind of moving our way through 250.50, 250.52, like what we're talking about now for the different types of electrodes. We're going to move our way through, okay? Now, listed ground plates are available that are 10 inches wide and 16 inches in length. So these meet the requirement to expose not less than 2 feet, okay? Now, 12 by 12 is 144 square inches times 2. You have 2 sides. That's 288 square inches, okay? As they are, these are 16 by 10 times 2. That's 320 square inches, okay? So typically you're going to buy those in a 16 inch by 10 inch. And again, you got 2 sides. So again, you're going to meet that without any problem, okay? And you would buy these. Now, I don't regularly see these if you go to a supply house. So if you're going to do plates, you better check before you go. Most people are probably not going to do plates. Where do I see plates again? As I mentioned it earlier in previous episode, part 3, where I saw the plates used the most was in like communication towers where the engineers believed that the triad ground rod system was what they wanted. And typically these rods were 10 feet long because the engineer can do that. Okay, they usually don't have to be but 8 feet long, but they wanted them 10 feet driven. And then in the middle of the triad, they wanted a plate installed. Okay, well, that's perfectly fine to do that, but they wanted to get a certain resistance to earth, and that's what they did, and that was their design. And so that's where I saw the plates being used. I've never seen a plate used for residential applications. Just never seen it. Never seen it used even in a commercial application. But I did see it used in some communication tower installations when I was back in Virginia, back many, many moons ago, okay? When I was a head of jurisdictions up in Alexandria, Virginia, we had an installation where that was taking place, okay? All right, the last one we're going to talk about in this episode, you get lucky, we have a short episode today, is 250.52A8. This is called Other Local Metal Underground Systems or Structures. Now, this one is short and sweet in the NEC. It says other local metal underground systems or structures such as piping systems other than gas piping systems, of course, and underground tanks and underground metal well casings that are not bonded to the metal water pipe. Okay, so this would be something separate than the metal water piping, which would be underground metal water pipe electrode. This could be the well casing. This could be underground metal tank. Now, the interesting thing here about 250.52A8, you better check with your AHJ. The NEC gives us very little on these, very little. It doesn't tell us how much surface area. I mean, obviously, if it's a underground tank, that's a lot of surface area, but it doesn't give us any direction here. So be very careful when you're using 250.52A8. You might have a water tank out in the ground, okay, and it has a lot of metal surface area on it that is in the earth, and you might want to use that. Okay, Well, if that's the case, do me a favor. Just check with your AHJ to make sure they're okay with it. That's all. Because that is a very broad 250.52A8. Okay, so just make sure you check that ahead of time. All right. Now, the reason I say you can't use gas piping is because it'll tell us when we get to the B portion of this, it's going to tell us, not the A, because we're in the A. We get to the B, it's going to tell us what can't be used as an electrode, and it tells us that gas piping systems underground cannot be utilized. So it should go without saying, right? But anyway, there you go. And so basically, that's what we got. And of course, you'll see here the next episode that we'll have, we're going to get in what's not permitted to be electrodes as we move our way through the grounding electrode systems and move our way into the installation practices and things like that. So going to be some great stuff coming up in future episodes. So this was a short one, gave you kind of a break. We ended up talking about all of the grounding electrodes. So make sure you go back and watch part 1, which talks about a metal underground water pipe electrode and all the nuances with that, what qualifies that. We also talked about in part 2, we talked about in-ground steel, that is the I-beams or that are driven in the earth or that are encased in concrete in the earth, at least 10 feet. That qualifies as the electrode. Then we talked about a concrete encased electrode. So that was 1/2-inch rebar in the footer, at least 20 feet, or 4-gauge copper. It could be horizontal or vertical, and it has to be in contact with the earth. That's the concrete in contact with the earth. So we covered that in that episode. In the part 3, we covered ground rings, and then we covered ground rods and pipes or conduits used as electrodes. Okay, that the pipe or conduit had to be at least 3/4 of an inch. Probably going to be difficult to drive, so you're probably not going to do that. Ground rods, if they're listed, they can be less than 5/8 inch diameter. If they are unlisted, let's say like a copper ground rod that doesn't have the mark on it from a listing, then it has to be at least 5/8 inches diameter. All of that's covered in the successions to the series. This is going to be a long-running series, so subscribe and buckle up as we move through it all. But hopefully you understand the electrodes, and if there's anything that you don't, feel free to comment or send us an email. Just go to our website. We have a Contact Us button there. Also, you can go to Let's Ask Paul over at paulabernathy.com. You can post a question there, and I'll answer it in an upcoming podcast, okay? In case you forgot about that, we do a lot of podcasts, and I love doing podcasts. So we got a lot more of these videos coming. Hopefully you got something out of this one today. Until next time, stay safe. God bless. And again, learn the National Electrical Code. It really will enhance your knowledge and make you a more well-rounded electrician. It's not just about pulling cables and running conduit. You got to know why you're doing it and why you need to be code compliant. Till then, take care.